Okay, now let's talk about the actual number. So I'm going to erase this. Is that okay?
Yeah.
So if I say that I want to do the cosine of pi over 6, because that's the actual question that you were actually asking me, right? Or do you already know how to do that?
Let's see. Yeah, like that's one example. I was just working on, I think, the second one on the list that I gave you. Just,
Is
you know,
that the
and that was it.
tangent inverse of 0? Is that the one? Is that the second
Yeah,
one?
it was that one.
Okay, let me explain the difference between the two, because I know
Okay.
that this messes people up. Okay?
Yeah.
When you have an, so I'll do it this way. Let's say I do. Okay, so I have two trig functions that look like they're exactly the same thing, right?
Yeah.
But this one is different because it has this in it. So this is
Okay.
what you need to remember. When they give you the regular trig function, they're looking for a number for the answer. So when they give you that angle theta, they're actually looking for a number. So this would be equal to root 3 over 2. When they have that inverse, they're looking for an angle, theta. So it's either going to be in radians or in degrees. So this would be either pi over 6 or 30 degrees.
Oh, okay.
The inverse function is asking for an angle. The regular trig function is asking for an actual number.
Okay. I see.
So, like for this question, and that's the question that was on your sheet, right? Is this asking
Yeah.
you for an angle or for a number?
So that's asking for an angle.
That's asking for an angle. So on my unit circle, I got to figure out what angle gives me a tangent of 0. Well, it's that one or that one, because the definition of tangent is equal to sine over cosine, right?
Yeah.
Do you know the trig definitions, or do you know it by opposite over adjacent?
Yeah. The whole SOHCAHTOA thing is how I initially tried to remember it.
Uh-huh.
And then like so sine is always like y when you're looking at, like,
Right.
I guess interval notation or
Right. Sine is always y, cosine is always x. So whenever you have like a coordinate and you're doing 1/2 and then root 3 over 2, this number is giving you the cosine of it, and that number is giving you the sine of it.
Okay. Yeah.
So in order to get this right, that means that this thing has to be equal to 0, right? So what number makes the sine 0? Well, that's right here, because this is -1, 0, right?
Yeah.
And this one is 1, 0. What is this number? Is that the sine or the cosine?
That's the sine.
That's the sine. What is this number, sine or cosine?
The sine.
That's the sine. So there's two places where this is true.
Okay.
It's either at pi or 180, depending on if you're doing degrees or not, or it's at 0 or 2 pi or 360. Remember, they're asking for an angle here.
Okay.
Does that make more sense now?
Yeah, so is that why, like, the question asks, give the answer in radian and also degree, because it could be both of those?
Because it could be both of those. Yeah.
Okay. So radian, it's just 2 pi, and then degrees, it could be 0, or it could be 360. I mean.
Right. Right.
Okay.
So can I ask you a couple of questions just to make sure that you have it?
Yeah.
Because I'm doing an awful lot of talking, so I want to make sure that you're putting down what I'm saying. So.
No, that's fine. I like that.
All right. So do this one for me.
All right.
And I want you to give me all of the angles that is true for. In radians and in degrees, just like your teacher asked you.
Okay. So would it be 45 degrees or pi over 4?
Yes. Good.
Okay.
There's also one more place that's true.
Oh, right, because it's positive. 135 degrees.
Uh-huh.
Or 3 pi over 4. 3 pi over 4?
Yeah, that's it.
Okay.
Okay. Now let's go the other direction.
Okay.
Let's do. And that was only going to give you one answer.
Let's see. That's why it's the 330 degrees.
That's what this is. Okay. But I'm looking for a number.
Oh, right. So since y is 1/2. Negative 1/2.
Negative 1/2. Good. Okay, let's do that again.
4. Oh, that's the 4. So that's the 1, 3, 5. So that's the negative square root 2 over square root 2.
Mm-hmm. Okay. I'm going to switch it up on you again because we haven't talked about these.
I was waiting for that. I was like, what happens after sin and cos?
Are you ready for this?
Yeah, because sometimes it confuses me. So I take it back. Maybe I'm not. Okay, so nope, I got confused.
Okay. All right, I'll walk you through this one.
Okay.
The first thing that we're going to do is we need to change this number. So I got to figure out what trig function that I know is related to secant. And I'm going to do it like that. The S's and the C's are always related to one another. So what other trig function do you know that has a C in it?
Cosecant?
Cosecant does too. Dang, I didn't even think about that.
Oh, I mean cosine.
Cosine. Because, they're reciprocal functions of one another, right? So, cosecant and secant aren't related to one another, right? So,
yeah,
that's true, right? So I'm going to put the negative 1 back, and then I just got to take the reciprocal of that number. You see what I did? I took the reciprocal of the trig function, and then I took the reciprocal of the number inside of the trig function. Those two things are equal to one another.
Oh, right, because secant is just 1 over cosine, right? Or cosine?
Yeah. Those two things are the reciprocal identities for one another, just like cosecant is a reciprocal of sine.
Okay. So if I look at that, I'm saying cosine should be the opposite of that, which is, so it'd be 1, 2, because then if you flip it for secant, it would be 2 over 1, and then that just makes it 2.
Right.
Okay.
So what's cosine of 1/2? What angle do you get in radians?
So I got pi over 360. Is that right?
That's pi over 3.
Okay.
And then what's the other place where cosine is equal to 1/2?
Pi over, oh, right. I see what you're saying. Five pi over 3.
Yes. And can you tell me the degrees for each one of these? Go ahead. Ask your question first. Go ahead.
So when I wrote down, the details from the unit circle, it helps like looking at it, because I can figure those real quick from that. Mm-hmm. But just curious, like if you want to do that in you couldn't remember the unit circle details or just to do it manually, is there like a fast way of doing it that way if you had to?
If you look at your unit circle, there's going to be a memorization thing, right?
Okay.
What bottom number do all the cosines of 1/2 have? So where the x value is equal to 1/2, what denominator do all of those angles have?
The 3?
The 3. That's how I remember it.
Okay.
I know it has to be some kind of pi over 3. I just got to figure out what quadrant it's in.
Okay. So this is a memorization thing to help out.
To help out.
Okay.
It will be, you know what? If you really want to learn that unit circle, go through the technique that I use to draw it. Do it 3 times, and you will have all the numbers memorized. I swear to God.
Yeah. Yeah, I might play that part back and just draw it out myself.
Yeah. You should draw it out at least 3 times, because all of my students that do that, they know it.
Yeah.
Because they see the pattern, because they're drawing the pattern themselves. You know?
Yeah, that's a good idea.
So besides that, that's kind of the only thing that you can do. It's like a memorization thing.
Sure. Okay.
And then you know that if I have the cosine of 1/2, that's equal to the secant. Sorry, that's equal to the secant of 2, right? So that's going to give you the exact same value. So all of these values are going to be the same for both of those. Just remember that whenever you see a -1, you're looking for an angle.
Okay.
That's the biggest thing. Because if your teacher hasn't done this to you yet, he will. And I might have actually seen a question like this on that sheet. I can't remember now.
Okay.
1 second. He might do this. Now, my question to you is, can you do that question?
Oh, I think I saw that one in the practice questions.
If you can, I can walk you through it step by step if you would like me to.
Okay, so it's sine and then in parentheses cos with the -1?
With the -1. So, just to recap, this part, is it looking for a number or an angle?
Looking for an angle?
Uh-huh. So I'm going to get some kind of angle. And then when I do the outside, I'm just sticking that angle into that space.
Okay.
So where is the cosine equal to -√3/2? What angles?
So it's negative cosine 3/2 is going to be negative cosine 3/2. Oh, right, wrong quadrant. Okay, so that'll be in the second. So that'd be 5 pi over 6.
And what's the other one?
And 150.
That's 150 degrees. And then what's the other angle? There's one more.
It'll be let's see. To be -5. Oh, right. It'll be 4 pi over 3.
No.
Wait.
If this is a 6, your next answer has to be a 6, because that's the pattern.
Yeah, okay, sorry. 7 pi, the next one.
Right, the very next one. So now all I got to do is just do this. I stick that angle in here. and then find out the number. So I'm going to do it twice because I got two different angles, right? So what is that equal to? What's the sine of 5 pi over 6?
The sine of it is 1/2.
What kind of 1/2? Oh, it's just regular 1/2. You're right. And then what's this one?
Negative 1/2.
Yep. And that's how you would do something that complicated.
Oh, okay. So you find both, and then you just
find both angles. So you work from the inside out. So you do the inside parentheses first, and then whatever that answer is, you just substitute it into the parentheses because it changes. This is the exact same thing as that, right?
Gotcha. Yeah.
And then you just do the next step. So you get rid of the inverse and write the angle, and then put the angle in there, and then find the number you're looking for.
Okay.
You want another one like that to try?
Sure.
Okay.
Let's see that. Oh man. Let's. Okay, so you're looking for a number.
You might actually have to have a calculator for this one.
Percent 30. Yeah, where do you start on that?
Okay. What is the sine of 30?
Sine of 30. Sine of 30 is 1/2.
And then I'm going to put that inside of this tangent function to figure out what that angle would be. So hit tan inverse of 0.5 and tell me what number you get. I made that off the top of my head. That's probably why it's not going to be pretty.
So we get like 0.46?
You have it in radians, don't you? Do you have your calculator in radians?
Let me see. Yeah.
Change it to degrees because I gave you a number in degrees. And you got to watch that when you're actually doing the questions, too.
Oh, okay. So I got like 26 and then a decimal?
Yeah, 26.6 if you round.
Yeah.
That's the right answer.
Oh, okay. I haven't used that before in the calculator yet. I didn't even realize it was there.
Yep.
Okay.
It's like the second button and then whatever your trig function button is, and that gives you the inverse.
Oh, I see. Okay.
Scale of 1 to 10. How are we feeling about that now?
Good. I just got to keep working on memorizing this thing to make it quicker. But
right. Okay.
Yeah, that feels.
Let's see what's next on our list.
Okay.
Does this setup work for you, John? Is it okay?
Yeah.
Good. Okay.
Yeah, it's going good. I like it.
Huh. Oh, it's just taking forever for the document to open. Okay. So a question like use your calculator to find it in radians, round to 4 decimal places, and then in degrees to the nearest tenth of a degree. Can you do those now in your calculator? Do you understand where those numbers are coming from now?
Oh, yeah, let me see. So is that number 3? Okay, right. So 10, 7.452.
Tell me how many degrees you got, just so I'll make sure you're doing it right in your calculator.
I got 82.4.
And now you got to switch the mode and go back to radians.
Oh, okay.
And then tell me what that is in radians.
I got, what does it say? Round to 4 decimals.
Mm-hmm.
So I got 1.4374.
Maybe I missed something. Oh, that's right. I thought it was a 2-2, but it's a 5-2. So, okay.
Okay.
Okay, so now can you do 4? Because we've done that. So can you do 4 now?
Yeah, let me let's see here. Oh, that was that one. You snuck it in there. Yeah, let's see if I can. So, okay, so let's. So, okay, pause this. So it's whatever. Okay, so cos, so cosine for the 2/2 is pi over 4.
Or
so then from pi over 4, I feel stuck.
Okay. Okay. So let me see if I can make that more clear. So we have tangent of cosine inverse of root 2 over 2. And so I'm going to write tan here with a parenthesis.
Okay.
And you already gave me the angle. So now, what is the tangent of pi over 4? So remember, here's our unit circle, right?
Okay.
And there's pi over 4. And the two numbers there are root 2 over 2 and root 2 over 2, right?
Yeah.
And that would be for cosine, comma, sine, right?
Right.
So I can write this like this. The sine of pi over 4 divided by the cosine of pi over 4.
Okay.
Because that's the definition of tangent. Tangent is sine over cosine.
Yeah.
So what is the sine of pi over 4?
2 over 2.
What's the cosine of pi over 4?
2 over 2.
So what would that be equal to then, if I simplified it?
It's just 1?
It's just 1. So this is equal to 1. See how I did that?
Yeah, in my head I was picturing both of those, the 2 over 2 divided by 2 over 2. And then that's where I was second guessing it, but okay.
That's it.
Nice.
Now there's another angle that you have to do because that's not the only place where this is positive, right? Where is the other place that it's positive? It's positive here, and it's positive some other place. Can you tell me the other place?
So it's cosine is 2 over. Oh, it's yeah, it's the 7 pi over 4.
Which is down here, right?
Right.
And what are our x and our y there?
It's 2 over 2 and then a negative 2 over 2.
So if this is the tangent of 7 pi over 4, our answer is going to be different. What's our answer there?
Negative 1?
Right. Right.
Cool. That's cool.
Okay, that is our time for today.
Okay.
I only wanted to do one session because I wanted to make sure that you were comfortable.
Okay. No, that was going good.
If you could do me a favor, when they ask you to write me a review, give me 5 stars and write me a review, please.
Sure.
And I guess, can we look at our schedules and figure out when we're going to meet again? And how many other things, because we've almost got all the way through this, right? We just have like 1 or 2 more questions left.
Yeah. And I'll definitely, we can set some up anytime, John, because I'll just move on to the next chapter.
Okay.
So how do you look for like the rest of, well, what is today, Wednesday? Do you have anything set up for Thursday or Friday nights?
I do have something set up for tomorrow night.
Okay.
Let Let me see what I'm doing on Friday.
Oh, and then that's Friday, so I don't know if you're working.
Hey, if you want to work, I got kids, so I'm not doing nothing. No stuff.
Oh, okay. All right.
But how about this? Is there any way that you could work on like a Saturday afternoon, or are you busy?
Oh, I'm usually good on. I usually do a lot of homework on weekends.
Awesome.
Around work, so that works for me. That's awesome.
Let's say 12 o'clock your time.
Oh, that's fine.
Which would be like 1 o'clock my time.
Yeah, that's good.
Okay. Do you want me to bill you for 3 sessions this time, or do you just want me to do it one at a time? How do you want to work?
Yeah, no, I mean, we might as well do more. How many? I mean, I'm good to do a few on. Do you mean do a few on Saturday in a row?
Oh, shit.
Or
no, or just, I need you to process the stuff that I'm teaching you anyway.
I got you. Yeah, we can do a like 3 if you want. That, I mean, that's good with me.
Okay, I think we're going to have enough stuff to cover to do 3. I just wanted to make sure that I wasn't overbilling you. You know what I'm saying?
Yeah. No, that's good. I can budget for that. That's good.
Okay. So I will see you Saturday at 1 o'clock my time, 12 yours.
Okay.
Stick you in here. And I'll send you an invoice probably either tomorrow or Friday for the 3 sessions.
Okay.
If you have any more work that you run across, please send it to me so I can look it over and try to figure out the best way to explain stuff. But it's trig, and I kind of know that stuff cold anyway.
Okay. That's awesome. I don't know what's to come next. I haven't really looked at it, but now I think it's running into, I haven't seen this stuff ever before, from the few classes I did to catch myself back up, since it's been a few years since I was in high school.
Right.
So yeah, I mean, as I get stuck, I'll definitely probably need some help for sure. So, and I like your style, so it works pretty good.
Oh, awesome. I like working with you too, man. I just want to make sure that I'm clear. And since you're a visual learner, I mean, it's just probably good seeing all the problems and stuff worked out and everything.
Yeah, I like it. I like how it's all set up. It's good.
Give me until tomorrow to put the videos up, because I'm going to bed now.
Sure.
And then I'll send you out. I'll send you a text message once I've posted them, and they'll be posted under John's playlist. Okay.
All right.
I'll just put them there. I told you the YouTube channel, right?
Yeah, I already subscribed to you.
Okay, awesome. You found me and subscribed. Awesome, sweet.
Yep.
If there's any other videos that you want to check out that are up there, I think I have like 100 and some videos up there, so you're more than welcome to.
Okay. Are those all your different like sessions you do explaining these?
Yeah, that's all my different sessions explaining stuff.
Nice. What are you in school right now, John, or you just tutor whenever you can?
No, I just tutor. I taught at a private school here in Richmond for 10 years. I graduated from UVA with my master's in 2000.
Okay.
So I've been teaching, ever since then. And then I guess about 6 years ago, I decided to just tutor full time because I wanted to have a family.
Yeah.
And it allows a lot of flexibility and stuff and freedom, especially when I can do clients online. Like it's a godsend.
I bet all the websites out there for math, they charge like these subscriptions, and YouTube videos are kind of hard to find exactly. I mean, It must be a pretty big market for just people needing help if they have all that, because some of those subscription costs are pricey.
Right.
I saw one, I think it was called Study Pug. I don't know, I can't remember. But I think it was like $70 a month or something like that.
Wow.
But anyway,
yeah,
I think having a lot of tutors.
There's a high demand for it because math and science teachers as a whole kind of suck.
Yeah.
And a lot of them have no personality whatsoever, you know?
Yeah.
And so people get so dried and bored out. They were like, I don't want the exact same thing that I'm getting at school because that's not helpful. You know what I mean?
Yeah. Yeah, it's just like when they fly over the details, you know, it's like I always go back to like, wait, why did you do that? And why did you do that? You know, and that's the stuff that textbooks usually fly over as well.
Right. And textbooks, well, you got to think about it. You got math and science guys writing textbooks. So a lot of them, I swear to God, have Asperger's. I swear to God.
Yeah. That's the truth. They've been doing it for so long. They've been doing it for like decades, and this stuff just comes out of them like 2 + 2 = 4, and
it's not that simple, man. It really isn't.
Yeah. But anyway, I like your style, man. So I think this is going to be good.
All right, man. Well, I will see you Saturday afternoon, or Saturday around noon, I guess, for you.
Yeah.
And
that'll work.
Have a good couple of days, man.
All right. You too. Thanks, John.
No problem.
All right. Bye-bye.
All right. Bye.